This is the exam review video for the Honors Geometry exam for Unit 4, Topic 1. Remember that you will be given these formula sheets on the exam, and they're going to be very important because, for instance, with this unit, we're going to be dealing with conic sections. So we'll need to know the formulas for parabolas, for a circle, and this can help you focus on what to study, what to memorize, versus what you don't need to memorize. There's 2 pages of exam formula sheets. So this page also has the ellipse and the hyperbola, which is going to be important for this topic as well. So we're going to start with questions 16 through 19, where you need to use the word bank to complete the following definitions. Words may be used more than once. So the word bank includes a center, focus, directrix, sum, difference, radius, equidistant, and foci. So 16 says, a circle is the set of points in the plane that are blank from a given point called the blank. The distance from the given point to every point on the circle is called the blank. Well, since we're dealing with the definition of a circle is a set of points in the plane that are equidistant from a given point called the center. The distance from the given point to every point on the circle is called the radius. A parabola is a set of points in the plane that are equidistant from a given point and that is called the focus. So remember, a parabola has one focus. An ellipse and a hyperbola have 2 focuses, which are pronounced foci. So a parabola is a set of points in the plane that are equidistant from a given point called the focus and a given line called the directrix. An ellipse is a set of points in the plane such that the blank of the distances from each point on the ellipse to 2 fixed points called the blank is the same. Well, an ellipse is a set of points in the plane such that the sum of the distances from each point on the ellipse to 2 fixed points called the foci is the same. A hyperbola is a set of points in the plane such that the difference of the distances from each point on the hyperbola to 2 fixed points called the foci is the same. So these are just the definitions of our 4 conic sections, which you just need to be able to know. You need to understand what they are, because there's a good chance that this question will come up on the exam in some way, shape, or form. So for items 21 and 22, we're going to sketch the following circles. Well, if you remember, and you have this on your formula sheet, a circle has the formula, or the equation, x minus h squared plus y minus k squared equals r squared. H and k is the center, and because these are in parentheses, they're actually the opposite, because x minus is the standard form. So x minus negative 3 will look like x plus 3. So we just look at it as the opposite. And then you just have to remember that the radius is r, but in this equation, it's r squared. So for 20, our center is going to be at 0, 0, and our radius is going to be the square root of 4, which is 2. So if I plot my center, I'm going to be going up 2, to the right 2, down 2, and to the left 2. And this is just a sketch, so it doesn't need to be perfect. My circles are definitely not perfect, but that's the sketch of our circle. For 21, our center is going to be at 2, -1, because these numbers are always going to be the opposite. Our radius is going to be the square root of 9, which is 3. So I'm going to go to my center, which is 2, -1, so it's going to be kind of right there. And I'm going to go 3 to the right, 3 down, 3 to the left, and 3 up. And then I'm just going to sketch that circle. And that's how you sketch a circle. For 22 and 23, write equations for the following circles and state the circumference and area of each circle. So the first thing we need to find is the center. We can kind of look and see where the farthest points of the circle are and meet in the middle. So here our center is going to be at 3, 2. And then we can see that from the center, we're going over 2 to the right, 2 to the left, 2 down, 2 up. So our radius is going to be 2. This means that our equation is going to be x minus 3, because it's the opposite, squared, plus y minus 2 squared equals the radius squared. And the radius squared is going to be 2 squared, which is 4. So this is going to equal 4. Circumference, the formula for that is 2 pi r. So my circumference is going to be 2 times pi times my radius, which is 2. And so my circumference is going to be 4 pi. And you can leave it in terms of pi. My area of a circle is pi r squared. So I'm going to do my area, which is pi, times my radius, which is 2 squared. So my area is going to be 2 squared, which is 4, so 4 pi. For number 23, I'm going to find my center. Again, look at my widest points of my circle, or my tallest and my shortest, and find the middle. So my center is going to be at -1, 0. And when I count 1, 2, 3, 4, 1, 2, 3, 4, I can see that my radius is going to be 4, which means that my radius squared is going to be 4 squared, which is 16. So my equation is going to be x plus 1 squared, because it's the opposite, plus y minus 0 squared equals the radius squared, which is 16. I can simplify this as well to x plus 1 squared plus y squared equals 16. Either answer is acceptable, but we always prefer to have the most simplified answer. My circumference is going to be 2 pi r, which is 2 pi times my radius, which is 4. So my circumference is going to equal 8 pi. And my area equals pi r squared. Well, that is going to be area equals pi times 4 squared. 4 squared equals 16, so my area is going to be 16 pi. Question number 24 says, write the equation of a circle whose center is at the point -1, 5 with the point 7, 20 on the circle. Well, our general equation for a circle is x minus h squared plus y minus k squared equals r squared. I know my center is hk, always the opposite, so x plus 1 squared plus y minus 5 squared equals r squared. Problem is we don't know what the radius is, but we can find it because we know that the point 720 is on the circle. So if I plug in those numbers, 7 for x, so 7 plus 1 squared, plus 20 for y, so 20 minus 5 squared equals r squared, I can solve for r. 7 plus 1 is 8, so 8 squared, plus 20 minus 5, which is 15, so 15 squared equals r squared. 8 squared is 64, 15 squared is 225, equals r squared. 225 plus 64 is 289, equals r squared. And if I square root both sides to solve for r is going to equal 17. So my equation is going to be x plus 1 squared plus y minus 5 squared equals 17 squared, which I actually find right here, and that's 289. Number 25 says, is the point 5,3 on the circle whose equation is x plus 3 squared plus y minus 2 squared equals 65. Show how you determined your answer. Well, I have x plus 3 squared plus y minus 2 squared equals 65. If 5,3 is on the circle, I will get, when I plug it in, I will get it to equal 65. So I'm going to plug in 5 for x, so 5 plus 3 squared. I'm going to plug in 3 for y, so 3 minus 2 squared equals 65. 5 plus 3 is 8, so 8 squared, plus 3 minus 2 is 1. 1 squared equals 65. 8 squared is 64, plus 1 squared, which is 1, equals 65. 64 plus 1 is 65. 65 equals 65. So, yes, 5,3 is on the circle. If I had gotten a number less than 65, that would tell me that the point was inside the circle. And if I got a number larger than 65, that would tell me that the point was outside the circle. For each equation of a circle, complete the square to put it in the form x minus h squared plus y minus k squared equals r squared. Then give the center and the radius. So we have to complete the square, and we have to do it in two parts. We have to do it for x, and we have to do it for y, if necessary. So for number 26, I see that I have x squared, but I don't have any other x's, so I don't actually need to complete the square for x. But with y squared, I've got y squared minus 6y, so I'm going to complete the square, and what I add to one side, I'm going to have to add to the other side. So to complete the square, I take b divided by 2 and square it. Well, my b is negative 6, so negative 6 divided by 2 squared is negative 3 squared, which equals 9. So I'm going to add 9 on both sides. When I do that, I can complete the square, which I've already done, but I can factor this. So I'm going to have y minus 3 squared, because what it factors into is always b divided by 2. And then 27 plus 9 is 36. And this is my equation of my circle. So I've put it in the form x minus h squared plus y minus k squared equals r squared. Now I need to find the center. And my center is going to be hk. So in this case, 0 is going to be my x, 3 is going to be my y. And my radius is r squared. So it's going to be the square root of 36, which is 6. For 27, I need to complete the square for both x and y. So I'm going to have x squared plus 2x plus something plus y squared plus 16y plus something. Now this negative 35 here, I'm not going to use it for completing either of these squares. So I'm going to add 35 to both sides, and 0 plus 35 is 35. Now again, I'm going to complete the square. Let's start with x. b divided by 2 squared is 2 divided by 2 squared, which is 1 squared, which is 1. So I'm going to add 1, and if I add 1 to one side, I need to add 1 to the other side. I'm also going to do b divided by 2 squared for the y's. So 16 divided by 2 squared is going to be 8 squared, which equals 64. So if I add 64 on one side, I'm going to have to add it on the other side. So x squared plus 2x plus 1 factors into x plus 1 squared. Y squared plus 16y plus 64 factors into y plus 8 squared. And 35 plus 1 plus 64 adds up to 100. And there's my equation of my circle. My center is going to be at -1, -8. And my radius is going to be the square root of 100, which equals 10. For items 28 through 30, sketch graphs of the following parabolas. For each graph, also graph the focus and the directrix. So we need to understand what the equation of a parabola means. And there's two ways of looking at it. So we're given both ways. One way of looking at it is x minus h equals 1 over 4p times y minus k squared. And then, we have it for y as well. Y minus k equals 1 over 4p x minus h squared. Again, these are given in the formula sheet, so you don't need to memorize them. I personally like this way because when the non-squared term is by itself, it tells me what direction it opens. So what I mean by this is the x minus h is by itself, so my graph's going to open in the x direction, either this way or this way. If p is positive, it's going to open towards the positive x. If p is negative, it's going to open towards the negative x. You can also look at this equation as y minus k squared equals 4p x minus h. So for the y minus k equals 1 over 4p x minus h squared, the y is by itself, so it's going to either open up if p is positive or down if p is negative. But this is also of the form x minus h squared equals 4p y minus k. It doesn't matter which one you prefer because either one will work. But I just wanted to explain parabolas in general. So looking at number 28, x squared equals 6y, I can tell that it's going to be of the form like this. So I can choose to rewrite the equation the way I personally like, which gives me y equals 1/6 x squared, or I can look at it the way it is, but this tells me that it opens up. And I also know that 4p is going to equal 6. So if I divide both sides by 4, p is going to equal 3/2, which is 1.5. My vertex is going to be 0, 0, because that's what hk is. And my focal width is 4p, and that equals 6. So when I graph this, I'm going to graph the vertex first, which is 0, 0. Since it opens up, my focus is going to be p units up, which is 1.5. So my focus is going to be about there. My focal width is 4p, which means it's 2p on either side of the focus. Well, 2p is 3. So 1, 2, I'm going to have a point here, and I'm going to have a point here of my parabola. Those are the only 2 points besides the vertex that I need in order to draw my parabola. And the last thing we need to put in is the directrix. This is my vertex. My directrix is p units below, and it's a line. So I'm going to go 1.5 units below, and that's going to be my directrix. It's always good to label your directrix with the equation. So y equals 3/2 is the equation of that line. For question 29, y squared equals 8x. As I said, I like to change the equation, so I'm going to divide both sides by 8 and get x equals 1/8 y squared. But you can look at either equation. This tells me it's going to open to the right because of x equals and p being positive. 4p is going to equal 8. So divide both sides by 4, p is going to equal 2. My vertex is going to be again at 0, 0. So let's plot that. There's my vertex. And my focal width, again, is 4p, which is going to equal 8. So because it's opening to the right, my focus is going to be p units away from the vertex, so 2 units away, but to the right. So this is my focus, this is my vertex. My focal width is going to be 8 units wide, so that means 4 units in either direction. So I'm going to have a point here and a point here for a focal width of 8. So I can connect my points. You should always make sure your graph goes to the edge. And then the last thing I need to put in is my directrix, which is 2 units back from the vertex. In this case, it's going to be a vertical line at x equals -2. Finally, for 30, we have x minus 2 squared equals -4y minus 1. If I divide both sides by -4, I'm going to have y minus 1 equals 1 over -4 x minus 2 squared. So this tells me it's going to open in the y direction, but p is going to be negative, so it's going to open down. 4p is going to equal -4. So if I divide both sides by 4, p is going to equal -1. My vertex this time is going to be 2, 1, because my x is here, my y is here, and my focal width is still 4p, which in this case is -4. So really the focal width is actually the absolute value, so it's actually going to be 4 units. 4 units wide, because distance can't be negative. So anyways, I'm going to graph my vertex first. So 2, 1 is right here. It's opening up, so my focus is going to be, it's opening down, so my focus is going to be 1 unit down. My directrix is going to be 1 unit up from the vertex. So my directrix is going to be y equals 2. My vertex is here, my focus is here, and then my focal width is 4 units, so it's 2 units on either side. Again, remember to go all the way to the edge of the graph, and there is my parabola. For items 31 and 32, write the equation for the parabola. Well, when I look at the parabola for 31, I can see that my vertex is at 0, 0. I can see that it opens up. And I can see that my distance from my vertex to my focus is 2. So this tells me that p equals 2. Well, you can write this equation in one of 2 ways. I'm going to start with the way I like, which is y minus k equals 1 over 4p times x minus h squared. Well, y minus 0 equals 1 over 4. P is 2, so 4 times 2, x minus 0 squared. This means we have y equals 1 over 8 x squared. So you can write your equation this way, or you can multiply both sides by 8 and get x squared equals 8y. For question 32, there is a mistake. This focus point is not correct. The focus is actually at -1.52. And we can also see that our vertex is at 1, 2. So our vertex is at 1, 2. We can see that it opens left. So this means p is going to be negative. And we can see that the distance from our vertex to our focus is a distance of negative 2.5. So P is going to be negative 2.5. So I'll start with the way I like it, which is x minus h equals 1 over 4p times y minus k squared. Again, you don't have to use this formula. So x minus h, that's going to be 1, equals 1 over 4 times p, which is negative 2.5, times y minus k, so y minus 2 squared. X minus 1 equals 1 over 4 times negative 2.5 is negative 10, y minus 2 squared. But if you like to write it the other way, you're going to multiply both sides by negative 10, and you're going to have y minus 2 squared equals negative 10 times x minus 1. For question 33, we're asked to look at the parabola below. Show that the point 8, satisfies the definition of the parabola by showing that the distance between the focus and the point, P88, is equal to the distance from the point, P88, to the directrix. So basically what we need to see is this distance equal to this distance? To do that, I'm going to use the distance formula. So the distance formula says the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm first going to look at the distance from F to P. So the distance is the square root of, now I need to know what my focus is. My focus is at 0, 2. So x2, 8, minus x1, 0, squared, plus y2, which is 8, minus y1, which is 2 squared. So my distance is going to be 8 squared plus 8 minus 2, which is 6 squared. So my distance is going to be 64 plus 36, which equals the square root of 100. So my distance is 10. So this distance right here is 10. Now, because this distance is a vertical line, I can actually count and see that I'm going 8 units to get to the x-axis, and then another 2 units for a total of 10 units. I can also use the distance formula though. This point is 8, negative 2, and see that distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So my distance is going to be x2, which is 8, so 8 minus 8 squared plus 8 minus negative 2 squared. My distance is going to be the square root of 0 squared plus 10 squared. So my distance is going to equal the square root of 100, which equals 10. So either way, we've proven that the distance from the point to the focus is 10, and the distance from the point to the directrix is 10. 10 equals 10, so they're both equal, and it satisfies the definition of the parabola. For items 34 and 35, sketch graphs of the following ellipses. So for 34, we're given x squared over 25 plus y squared over 16 equals 1. If you remember, and the formula is given on the formula sheet, we've got two different types of ellipses. We have horizontal ellipses, where x minus h squared over a squared plus y minus k squared over b squared equals 1. So for ellipses, the a, which is going to give us the vertices, is going to be under the variable that the axis is parallel to. So, for instance, in this equation, the major axis, so that's the length of the longer part of the ellipse, the major axis is made up of 2a, and that is under the x. So our major axis is going to be parallel to the x-axis, saying that it is a horizontal ellipse. The other one we have is a vertical ellipse, and that's of the form x minus h squared over b squared plus y minus k squared over a squared equals 1. So again, our a giving us our vertices is under the y, so our major axis is going to be vertical. It's going to be parallel to the y-axis. So 34 says x squared over 25 plus y squared over 16 equals 1. I can see that my larger number is 25. It's under the x squared, so I'm going to have a horizontal ellipse. A squared equals 25, so I know the square root of a squared is a, the square root of 25 is 5. B squared is going to equal 16, so b is going to equal 4. And I can tell that my center is at 0, 0. So the first thing I should do is plot my center, which will be right here. Not that I need to actually plot that point, but it's so much easier to do that to see the points of our ellipse. Because it's horizontal, I'm going to be going right and left to find my A, which means I'm going to be going to the right 5 units and to the left 5 units. And those are going to be my vertices. Then I need to plot my co-vertices, which is my minor axis. So I need to go up 4 units and down 4 units, and those are my co-vertices. So I can plot my ellipse, and it's going to look like that. Obviously, it's just a sketch. Mine looks more like a football than an ellipse, but that's okay. For 35, y minus 1 squared over 9 plus x plus 3 squared over 4 equals 1. I don't really like looking at ellipses with the y first. I think that's more of a hyperbola thing. So because addition falls under the commutative property, I'm just going to rewrite this as x plus 3 squared over 4 plus y minus 1 squared over 9 equals 1. Because remember, a plus b equals b plus a. This way, I can see that my larger number is under my y, so I'm going to have a vertical ellipse. A squared is going to equal 9, so a is going to equal 3. B squared is going to equal 4, so b is going to equal 2. And my center is going to be at negative 3, 1, because it's the opposite. So I'm first going to plot that. My center is going to be right about here. And I'm going to do my major axis first. So because it's vertical, I'm going to go up 3 units, and I'm going to go down 3 units. And that's going to give me my major axis. And then I'm going to go 2 units to the right and 2 units to the left to get my co-vertices, which make up my minor axis. I can connect my points, and there's my ellipse. For items 36 and 37, write equations for the ellipses below. So in this case, we need to find out what our center is, so I can find the widest part of my ellipse and find the middle. So my center here is going to be at the origin, 0, 0. And then I'm going to look. My major axis is vertical. That's 2a. So I'm going up 5, meaning my a is going to be 5. And I'm going to the right 1, which means my b is going to be 1. So because this is a vertical ellipse, I'm going to have the equation of the form x minus h squared over b squared plus y minus k squared over a squared equals 1. It's a vertical ellipse. X minus 0 is x, so I'm going to have x squared over b, which is 1. 1 squared is 1. Plus y minus 0, which is y, so y squared over a squared. A is 5, 5 squared is 25, equals 1. So the equation of my ellipse for 36 is x squared over 1 plus y squared over 25 equals 1. For 37, I need to find my center. So I'm going to look at the widest part of my ellipse, find the middle, and it's going to be right here. And my center is going to be 1, 2. I can see that it's horizontal, so I'm going to have an equation of the form x minus h squared over a squared plus y minus k squared over b squared equals 1. Well, now I need to find a and b. Because it's horizontal, my A is going to be this distance, my B is going to be this distance. So A is going to be equal to 4 units, and B is going to be equal to 2 units. So putting this all into my equation, x minus 1, because that's my h, squared, plus y minus 2 squared. And then I'm going to have that over a squared. Well, a is 4, so 4 squared is 16. B squared is 2 squared, which is 4, and this is going to equal 1. So my equation for 37 is going to be x minus 1 squared over 16 plus y minus 2 squared over 4 equals 1. For 38, it says to determine whether the point 2, 1 is on the ellipse whose equation is x squared over 9 plus y squared over 4 equals 1. Well, all we need to do for this is plug the point, substitute the point into our equation. We have 2 squared over 9 plus y, which is 1 squared over 4, equals 1. Well, 2 squared is 4, so 4 over 9 plus 1 squared is 1 over 4 equals 1. So I need to know if these are, the sum of these equal 1. In order to add fractions, we need to have the same denominator. So to get the same denominator, I'm going to multiply my first fraction by 4 over 4 because I'm really multiplying by 1. And I'm going to multiply my second fraction by 9 over 9, which is really me multiplying by 1. So 4 times 4 is 16. 9 times 4 is 36. Plus 1 times 9 is 9. Plus over 4 times 9, which is 36. And I want to know, does that equal 1? Well, now that they have the same denominator, I can add my numerators, keep my denominator. 16 plus 9 is 25, and 25 over 36 does not equal 1. So 2, 1 is not on the ellipse. For items 39 and 40, sketch the following hyperbolas. So we have two types of hyperbolas. We have a horizontal hyperbola, meaning that my graph is opening in the x direction. It's opening up horizontally. So the equation of that is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. Hyperbolas, the x and the y are what change order. The a and the b stay the same. Whereas an ellipse, the x and the y stay the same and the a and the b changed order. We also have a minus instead of a plus. So the other type of hyperbola is a vertical hyperbola where it opens up in the y direction. So this means that y is going to come first. Y minus k squared over a squared, because that stays the same, minus x minus h squared over b squared equals 1. These formulas are on your formula sheet, but remember, to keep these things in mind for when you're graphing them. So for 39, we have x squared over 4 minus y minus 2 squared over 1 equals 1. First thing I should find is the center. That's that hk. And in this case, it's going to be 0, 2. So I'm going to plot that point at 0, 2. This is my center. My a squared is going to be equal to 4, so a equals 2. My b squared is going to equal 1, so b is going to equal 1. Since x comes first, I know that it's going to be a horizontal hyperbola. Since it's a horizontal hyperbola, I'm going to go a units to the right and to the left to give me my vertices of my hyperbola. So I'm going to go 2 to the right, 2 to the left. I'm going to go up and down 1 unit because this is what's going to help me make my box that's going to allow me to draw in my asymptotes. So I'm going to connect my 4 points that I made into a box. Remember, it needs to be a dashed box because it's not actually part of the graph. And my asymptotes are the diagonals of my box. So you should graph those in. They are going to be dashed lines as well because they're not part of the graph. I can also look at the slope to see how to graph them. This is going up 1 over 2. So I'm going to go up 1 over 2 to get that point. Or down 1 over 2, so I can go down 1 over 2. So my first asymptote is this line right here. It goes through the diagonal of my box, meaning it goes through my 2 corners as well as my center. Same thing in this direction. I'm going to go up 1 over 2, so I'll go up 1 over 2 to get my other point. And I'm going to go down 1, back 2, so I'll go down 1, back 2 to get my other point. Graph these points, and there are my 2 asymptotes. So my actual hyperbola is going to be in between my asymptotes going through the vertex. You don't need any other points than the vertex, just as long as it goes along the edges of the asymptote, because remember, an asymptote means that the graph gets closer to it but never actually touches it. For question 40, we have y squared over 9 minus x squared over 9 equals 1. So first of all, my center is going to be 0, 0. It's at the origin. And because y comes first, I can tell it's going to be a vertical hyperbola. A squared is going to equal 9. B squared is going to equal 9. This means A equals 3 and B equals 3. So I'm going to go, first of all, up 3 and down 3 to get my vertices of my hyperbola. But I'm also going to go to the right 3 and to the left 3 to help me make my box. Again, my box is going to be connecting the 4 points that I found made by A and B. And then my asymptotes, which are also dashed lines, are going to go through the diagonal of my box. Sorry, not the most accurate, but you understand what I'm doing. Finally, I have to graph my hyperbola. It's going to go through my vertices, which are here and here, and it's going to run along my asymptotes. So I have a hyperbola here, and I have a hyperbola here. And that's my graph. For items 41 and 42, I'm going to write the equation for the hyperbola below. So the first thing you need to find is your center. My center for number 41 is going to be at 0, 0. I also know that it's a horizontal ellipse. I can see that. So my equation is going to be when my x comes first, so x minus h squared over a squared minus y minus k squared over b squared equals 1. So now I need to look at my graph and find out what a and b are. Well, a is the distance from my center to my vertices, so it's going to be this distance right here. So a is going to equal 2. B is my distance to the other side of my box, so in this case, b is also going to equal 2. So I can put this in my equation. I've got x minus 0 squared over 2 squared minus y minus 0 squared over 2 squared equals 1. Simplified, I have x squared over 4 minus y squared over 4 equals 1. For 42, my center is going to be at negative 1, 0. I can see that it is a vertical hyperbola, so my equation is going to have y first. Y minus k squared over a squared minus x minus h squared over b squared equals 1. Next, I need to find my a and my b. My a is going to be the distance from my center to my vertex. So in this case, I can see a is 3. B is going to be the distance to my other part of my box. So in this case, b is 2. And we're going to put this in our equation. So we're going to have y minus 0 squared over 3 squared minus x plus 1 squared over 2 squared equals 1. Simplified, this is going to give us y squared over 9 minus x plus 1 squared over 4. Sorry, that is hard to see. Let me erase this. X plus 1 squared over 4 equals 1. And that is the equation of our hyperbola. For question 43, how many points of intersection do the graphs of the circle x squared plus y squared equals 16 and the parabola y equals x squared have? You may use the grid below to help you. I'm going to use the graph because I think that's the easiest way to see it. So let's start with our circle. We have x squared plus y squared equals 16. So our center is going to be at 0, 0. And our r squared equals 16, so our radius is going to be the square root of 16, which is 4. So if I plot that, I'm going to be going 4 to the right, 4 up, 4 to the left, and 4 down. And I'm going to get my circle. My parabola is of the equation y equals x squared. Well, remember that the equation of a parabola is y equals 1 over 4p x squared. So 1 over 4p must equal 1 because the coefficient of x squared right here is 1. So if I cross multiply, I'm going to get 1 equals 4p, divide both sides by 4, and p is going to equal 1/4. Now, because it's y equals x squared, I also know that my parabola is going to open upwards, and my vertex is going to be at the origin, 0, 0. And I know that my focal width, which equals 4p, is going to be 4 times 1/4, which is 1. This means I'm going to go half p in either direction of the width. So my vertex is going to be here at the origin. I'm going up 1/4 to get my focus, and I'm going down 1/4 to get my directrix. Y equals negative 1/4. At my focus, I have a focal width of 1, so I'm going to be going half a unit in either direction. So this is a very narrow parabola. I can see from here that I'm going to have 2 points of intersection, because my circle intersects with my parabola at those 2 points. You don't need to find out what they are, you just need to know how many. These points down here do not count because we really are looking at the parabola. Even though the directrix is part of the graph, it's not actually part of the parabola. Think back to quadratics. Our parabolas are U-shaped graph. For 43, sorry, that was 43. For 44, we're asked how many points of intersection do the graphs of the circles x minus 2 squared plus y squared equals 4 and x plus 2 squared plus y squared equals 4 have? So we're going to graph both of these. Let's start with x minus 2 squared plus y squared equals 4. I can see that my center is going to be at 2, 0, and my radius, well, I can see that r squared is 4, so my radius is going to be 2. So if I plot that, 2, 0 is my center, and I'm going 2 points, 2 units in either direction to get my circle. Sorry, my circle could be better, but that's okay. My other equation is x plus 2 squared plus y squared equals 4. My center is going to be at -2, 0. And my radius, again, r squared equals 4, so my radius is going to be 2. So I'm going to plot -2, 0, and then I'm going to go 2 units in either direction to get my circle. And from this, I can see that I'm going to have 1 point of intersection. And this is the end of the exam review for Unit 4, Topic 1 of Honors Geometry.